call Katie.
Okay.
We lose Katie.
Okay, you're not
Where's
here.
Katie? Hi, Katie.
I don't know who that is.
I know you're celebrating that you're not here with them.
Hey, Evie.
Sorry, I forgot to start recording, so we started without you. So let me backtrack for a second. So what we're trying to do here is I want to find the area between the function x cubed and the x-axis between -2 and +2. And so they pointed out we should do a definite integral to find area. So we've set up a definite integral from -2 to +2. And we have just remembered how to integrate an incredibly difficult x cubed. And we were at last debating what do you get when you sub 2 into that function?
4.
4. Minus?
4.
Is it
Four.
-4 though, so it should be
Is it -4?
No.
Take it to the fourth power.
Fourth power will be +4, so I get 0.
I told you.
Oh my God, right?
It has an area of 0?
Sure, why not?
That makes sense.
It's totally possible.
Well, what shape is x cubed?
Parabola.
It's Parabola. So if I plotted this 1, 1, can I assume we know how to plot a parabola?
No.
Yeah. You go 100, 100, then you make it stupid.
You cube the numbers. Well, I've cubed it already. 0 cubed is 0, 1 cubed is 1, 2 cubed is 8.
Yeah.
1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, now, do I need to plot past 2?
Good, but didn't get it. Cut hurt.
Do I need to plot it past 2? Do I need to go to 3?
Go.
Well, this thing said graph it from -2 to +2. Now, I want the area between this curve and the x-axis. So where is that area? I need not that. About. Well, okay, if I come up here and I cut it off at 2, the area would be in that little region up there. But what is it when I'm over here on the negative side? Yeah, it's -2 and it's coming down because I have to be always between the curve and the x-axis. So if this will let me fill it in, I hope. Oh, seriously? It will only fill in my squares. That's annoying. And I'm on the wrong side. Yikes. No. It used to fill in over the squares, and then it stopped. They updated the software, and then it doesn't work the same anymore. I don't get it. Okay, so yeah. So why did I get an area of 0? There's area there.
Negative area and positive area.
Exactly. When you are above the axis, it gives you positive area. But if your area is below the axis, it gives you negative area. So when you actually want to calculate area, you're going to have to set it up a little differently. You're going to have to draw the graph first so you can see when is it above the axis, when is it below the axis, so you can set it up right. We actually should have then gone, okay, I always work left to right. So starting on the left, we're starting at -2. How far does the area go that's below the axis? From an x-coordinate of -2 to an x-coordinate of where?
0.
To 0. So you're going to set it up -2 to 0. But since it's below the axis, it's going to be negative. What do I have to do to it to get it to become positive? If you have something negative, what can you do to change it to a positive? Add another negative. So if it's below the axis, you're going to put a negative out front. And you're going to integrate it, that function. Then you're going to go do it as a second piece. You're going to add the second piece on, and it's going to go from what x-coordinate to what x-coordinate? 0 to 2. And because it's above the axis, we'll leave it positive x cubed. And so you actually will have to do 2 integrations. Which, once again, this isn't too difficult. We already know it's -4, or x to the 4th over 4. And subbing these in will get me what? 0 in there gets me, yeah, you're giving me the whole area. So that's going to give me 0 minus, when I sub -2 in there, That's going to become 4, but that negative is not to the 4th power. I'm going to get a negative 4, so it's actually going to become a plus. And then you're going to have to do the same integration over here from 0 to 2, which is going to give us 4 minus 0, and it is going to actually add up to 8. Okay, now because you're finding area, you have to actually put a label on this. There you go, units squared, because we have found area.
What we gotta do?
That's all we got to do. You would be correct.
Here we go.
That is an easy one.
Probably the only easy one.
Remember, Sharon starts out with the hard one.
Yep, the second one's always the hardest.
The second one is always the hardest?
Yeah.
Here we go. Oh, no, not today.
We challenged her now.
I actually have, look,
How many pages do we have today?
5.
Oh, I was good.
Yeah.
Yes.
I was good.
Causing problems again. You realize that? Don't cause problems.
I can't wait for the day.
Oh, that's
What am I for? What just happened?
Oh, that's why.
Well, remember, I do
No, I'm the last one. Like, I'll take it.
Okay, I want to do this particular little function from 0 to 7. Now, I'm actually doing this one to remind you that you know how to graph this.
No.
What will that shape be? It's a parabola, but my question to you is, where's the vertex when it's not in the form where you could read the shifting?
Oh.
Negative B over A.
Negative
B over A. 2A.
2a.
Everyone got it?
Negative b over 2a will give you the x-coordinate of the vertex. So in this case, a, actually I would prefer to write it that way. In this case, what's a negative b?
3.
Negative b is not, yeah. Negative b is actually positive 6 over 2 times 1. So yes, our x-coordinate of the vertex is 3. We also need the y-coordinate of the vertex. So where do I put the y? How do you get the y-coordinate of the vertex? You sub it back in, yeah. You put 3 in the function and go, what's 3 minus 6 times 3 plus 5? Seriously, is that high?
No. 9 minus.
Oh, it's negative 9 plus 5. Okay. Okay. So we're going to end up with negative 4. So we know the vertex is at 3, negative 4. How do we plot a parabola? Thank you. Yes, you do. You go 1, 2, 3, and you square them and get 1, 4, 9. Okay. When do you have to multiply the y-coordinates by another number? Yeah. If there was a 2x squared, you would have to double all your y-coordinates. Okay. But this is a nice normal one, so yes, we can just plot 1, 1, 2, 4, 3, 9. Now, do I want this entire parabola? Where does this thing want me to go between? They want me to go from 0 to 7. So if I'm going from 0 to 7, I've got to figure out where are those areas at that I would be trying to find. Where's my highlighter? Right there we go. Okay. So from 0 to 7, for the first part, whoa, that's a little fat. Let's not highlight with that big of a highlighter. Let's go.
Yeah, I'm sorry. You can't be picking on Indian people.
I'm sorry, the highlighter was wide. Excuse me. Okay.
You feel a little
But
more
okay,
nice,
that's 0 to 1. Then I got to go 2, 3, 4, 5, 6, 7's clear out here quite a ways out. 7's clear out here, so I'm actually talking about I didn't draw this far enough up. This baby's really coming up here somewhere. So I'm talking about area, what area do I do over here where the vertex is at?
That whole area?
I'm doing this whole area below the axis. So I would be talking about that area. And then I would be talking, once I get past that, I'm talking about this area clear up here. So there's a good question. Do we have to do 3 integrations to get this?
Really stupid.
We sure do. It's always the area between the curve and the axis. So if you're below the axis, between the curve and the axis, it means you have to go above it.
Alright, let's get all 3 done.
So it's always from wherever the curve is to where the axis is. So yes, we would be setting up 3 integrations here.
X cubed over 3 minus...
Okay, whoa. Just set it up first. From where to where is the, I work left to right, so from 0 to what?
1.
0 to 1, is it positive or negative? Positive. So 0 to 1 with x squared minus 6x plus 5.
We got the X cubed over 3.
I don't want you to integrate it right now.
Why not?
I want you to set the whole thing up, and some of these are going to say just set them up, don't work them out, or I'll let you work them out by calculator. Okay, so that's the question. Would I subtract the middle one? Yes. It's below the axis, so I would go minus then from where to where? 1 to 5. Same function. Function didn't change. And then I would have to go above the axis
5 to
again,
7.
from 5 to 7, with the same function again. Okay, you will notice on your assignment sheet, some days it will say, like today, your first 2 problems say evaluate with CAS. What's that mean? Use it, do them, put the whole integration in your calculator and do it. Then when you get down to the other part, it'll say evaluate all by hand, which means I gotta give you a calculator. You're gonna need it through this section. I want you to get your calculator back too because you're doing, well, I guess I can get out a TI-89 and live with that, but yeah. It's fair.
I know where it is. You should make a note on the announcement and be like, we have 2 missing calculators. You should all, we have Brad, but everyone should check that off and make sure they're not having an extra. We don't see announcements anymore. I won't go announce at the end of the day.
I'd be better off to text all my students.
That would work. What if it's not one of your students that has to calculate? Somebody probably stole it from me.
That's a problem. That could be. Because it could have been somebody, that happens in chemistry physics, somebody grabs the calculator and takes it and they didn't think about it. Okay, one like this where you have this many parts, I would probably not make you work it out by hand because it takes a while to work all that out by hand. So, in the case of this one, I will tell you that it turns out to be 71/3 when you get done.
Doing the math over here.
I would put that whole thing in the calculator, just integration plus integration plus integration, let it do it all at once.
Lucky.
14 minutes.
Oh, thank you for the warning. So, don't forget to put your unit squared on it. Okay, this is a good place to pause.